Hello viewers, Ronald taking you through the story for O-level physics. And this video we're going to go through the topic of commercial electric energy. So this video is under current electricity and is suitable for students in both senior 3 and senior 4. So current electricity, we have already covered the first part of the calculations, second part, third part, and fourth part of the calculations. And now we are going on the last part of calculation, which is commercial electric energy. And notes are available in the book called Mastering O-Level Physics, Volume 2. So this Volume 2 is the one for Senior 3 and 4. Volume 1 is for Senior 1 and 2. We also have a topical question bank of O-Level Physics and a topical question bank of O-Level Mathematics. So for copies of these books, you can contact the author on any of these two contacts. So you start our topic of commercial electric energy. So shall write and say that there are always charges for electricity consumed that the electricity board gives for us for payment, and they use our meters to estimate the energy consumed. Now this energy consumed is measured in kilowatt hour. So this K, small k, capital W, small h means kilowatt hour, and we shall use it more frequently. So use this kilowatt hour as the commercial unit of electricity or electrical energy because a watt second is very small. We can't use watt second because it will be very small, so we use hours. Therefore, by definition, a kilowatt hour is the electrical energy used by a rate of working of 1000 watts for 1 hour. Alternatively, you can also define it as the quantity of electrical energy converted into other forms of energy by a device of power 1000 watts in 1 hour. So now what we are going to do, we are going to derive what we shall be using to calculate the total cost for the energy consumed. So we know that 1 watt is equal to 1 joule per second. Therefore 1 kilowatt will be equal to 1000 joules per second. And therefore that means that 1 kilowatt hour is equal to 1000 joules per second, which is a kilowatt multiplied by 1 hour. And when you convert these hours to seconds, you know that 1 hour is equal to 3600 seconds, so you shall convert to give you that. Then when you use the calculator to multiply, you shall come up with this. Now the per second and this second cancels, remain with only joule. So that means, and when you convert to mega, so this was joules, and when you convert to mega, it means that we divide by 1 million. That's why we get now 3.6 megajoule. Now the cost of electrical energy calculation, we shall come and write and say that the number of units used is equal to electrical energy consumed in kilowatts. And know that energy is equal to power times time. So the power will be in kilowatt and the time will be in hours. Those are the number of units used. Therefore the total cost will be number of units used times the rate per unit. So the rate per unit is got from the electricity board. So the rate per unit is the cost per unit of electrical energy consumed. That means that the formula shall be using is that total cost is equal to power in kilowatts multiplied by the time in hours. Time was the cost per unit. So that formula is very vital, is what we shall use in this video. So we start with question 1, which came from UNEB 2018 paper 1 question 33, and it says the daily cost for using two 50-watt bulbs is shillings 200. If 1 kilowatt hour of electricity costs shillings 400, find the time for which the bulbs are lit daily. So first of all, we shall quote the formula. Total cost is equal to 1 kilowatts times time in hours times cost per unit. Then we shall substitute. So they said the cost is shillings 200, that's why I shall put under cost. Then here with the power, they said 50 kilowatt, but they are two bulbs. They are two bulbs, so therefore it will be 2 times 50 to give you this power. But this power will be in watts. If you look at this, it will be in watts. That is why we have to divide by 1000 to make it a kilowatt. Okay, that is here. So we finish the cost. Then the time is what they want, so we should leave it as an unknown. Then the cost per unit, they said it is 4 shillings 400. So now here we have only one unknown. We shall simplify and make it the subject. That means C is the correct answer. Then question 2 came from UNEB 2014 paper 1 question 26, and it says the total cost of running a lamp rated 7.2 volt 3 ampere for 5 hours is shillings this. Find the cost per unit of electricity. So still we shall do the same. We shall first quote the formula, then we substitute what is given. The total cost was this. Then the power, remember power is IV, so I times V gives you this power, but it will be in watts, so you divide by 1000 to make it kilowatts. Then the time is 5 in hours, so it is okay, and this is what they want. So when I make it the subject, I'll come up with this, and that means that part A is the correct answer. Then question 3 came from UNEB 1993 paper 1 question 3, and says a house has 4 75-watt lamps and 5 100-watt lamps. What will be the cost of running the lamps for 10 hours if the cost per kilowatt hour is this? So you first got the formula still, then we substitute. Now the power, there are 4 70-watt lamps. That gives you this 4 times 75. Then there are 5 100-watt lamps. That gives you this 5 times 100. Now that will be in watts, so we shall divide it by 1000 to get the kilowatt. Then the time, they said 10 hours. And the cost per unit is this kilowatt hour, which is 50. Then we use the calculator, we shall come up with this, and that will be the cost. Therefore, B is the correct answer. Then question 4 came from UNEB 1990 paper 1 question 37, and says calculate the cost of running 4 40-watt lamps and 3 60-watt lamps for 5 hours if electric energy cost is the shillings 10 per kilowatt hour. So still we shall quote the formula, then we substitute. So there are 4 40-watt lamps, that gives you 4 times 40, and 3 60-watt lamp, that gives you 3 times 60. It is in watts, so we shall divide by 1000 to make it kilowatt. Then the time is 5 hours and the cost per unit is 10. Then we shall use the calculator and come up with the correct answer as part B. Then question 5 came from UNEB 2001 paper 1 question 24, and it says How many kilowatt hours are used to run? Roman 1. 8 kilowatt cooker for 1 hour. 3 kilowatt immersion heater for 40 minutes. And 960 watt hair dryer for 20 minutes. So energy consumed, first of all, this is 8 kilowatt for 1 hour. So power times time is that. Then 3 kilowatt hour for 40 minutes. So power is that. Time must be in hours, so we convert the 40 minutes to hours. Then 960 watts for 20 minutes. This has to be in kilowatts, so you divide by 1000 to make it kilowatt. And this 20 convert to hours by dividing by 60. Then when I add, I'll come up with this, and that will be the answer. Then question 6 came from UNEB 2007 paper 1 question 14, and it says the initial and final meter reading after 1 month of electricity supply is 21,000 kilowatt hour and 21,800 kilowatt hour respectively. Calculate the cost of the power consumed if each unit costs shillings 75. So you know that total cost is equal to number of units used times the rate per unit. So number of units used, you shall get subtract. At the beginning, initial it was this reading, final it was this reading. So the number of units used will be got by subtracting the 2. Then the rate per unit is here, so shall multiply. So when I multiply the 2, I'll come up with this 800 times 175, which is C. Then question 7 came from UNEB 1992 paper 2 question 2C, and it says calculate the cost of running an electric fire for 2.5 hours if the electric fire takes a current of 13 ampere and on a 100 volt appliance, and each unit costs shillings 40. So first we shall code the formula. Then we shall substitute. Now power is IV, so current times volt. That gives you power in watts, so you have to divide by 1000 to make it kilowatt. Then the time was 2.5 hours, that is 2.5, and the cost per unit is 40, shillings 40. So when I multiply, I come up with 1 shillings 130, and that's what they wanted. Now we shall go to question 8. Question 8 says, came from UNEB 1991, paper 2, question 6B, Roman 2, and it says, a house has 1 100 watt bulb, 2 75 watt bulbs, and 5 40 watt bulbs. Find the cost of having all these bulbs switched on for 2 hours every day for 30 days at a cost of shillings 20 per unit. So still we shall code the formula. First of all, total power consumed, we have 100 watt, which is that 1 times 100. Remember it is still in watts. 275 watt, so 2 times 75, and 540 watt to give you 540 watts. Okay, then we shall come and code the formula. But the formula, the power should be in kilowatts, so we shall divide by 1000 to give you the kilowatt. Then the time, it was 2 hours for 30 days, that gives you 2 times 30, and the cost per unit was 20, and that gives you the cost they wanted. Then question 9 came from UNEB 2017 paper 2 question 5C, and it says 5 equal electric bulbs are switched on for 8 hours a day for 30 days. If each unit costs shillings 600 and the total monthly bill is shillings 43,200, find the power rating of each bulb. So let P be the power for each bulb. Therefore, we shall come and quote the formula, then we substitute. Total cost was this. Power in kilowatts. Remember they said there are 5. So it would be 5 times P, but that P is in watts. Therefore, we shall divide by 1000 to make it kilowatt. Then the time they said 8 hours for 30 days. That gives you 8 times 30. And the cost per unit is shillings 600. Then simplify and make P the subject, and that will be the rating of each bulb. Then question 10 came from UNEB 1997, paper 2, question 8, and it says Abbott paid an electricity bill of shillings 180 after using 2 identical bulbs for 2 hours every day for 10 days at a cost of shillings 60 per unit. Roman 1. Determine the power consumption by each of the bulbs. And Roman 2. State the energy changes that occur in the bulb. So you come and say let P be the power for each bulb. Quote the formula and substitute. Total cost, there are 2, so it will be 2 times P it will be in kilowatts, then divide by 1000 to make it, 2 times P is watts, then divide by 1000 to make it kilowatt. 2 hours for 10 days, then cost per unit. Then simplify and make P the subject. Then for Roman 2, they wanted you to state the energy changes that occur in the bulb. So electrical energy is converted to heat or internal energy, which is converted to light energy. Then question 11 came from UNEB 2008, paper 2, question 4C, and it says an electric fire, a lamp, and electric drill rated at 2000 watts, 100 watts, and 300 watts, respectively, are connected in parallel across a 240 volt mains. Find Roman 1 the power taken from the mains, and Roman 2 the current supplied by the mains, and Roman 3 the cost of running these appliances for 12 hours if 1 unit costs shillings 200. So Roman 1 total power will be 1000 plus 100 plus 300, which is 2400 watts. Then for Roman 2, power is equal to IV. Substitute for power, I is unknown, substitute for V, and that will be the current. And Roman 3, we shall quote the formula, then substitute. The power is this, convert to kilowatts, the time is that 12 times 12, and the cost per unit is 200, which gives you that as the total cost. Then question 12 came from UNEB 2013, paper 1, question 50, and it says a 3 kilowatt immersion heater is used for 8 hours each week, and a 200 watt filament lamp is used for 5 hours daily in a week. Find Roman 1 the total energy consumed each week. So total energy consumed will be 3000 times 8 times 3600. So this one, convert to watts, it gives you 3000. Then the hours, convert to seconds, it gives you 8 times 3600. Then for this one, it's already in watts, so it is 200. Then 5 hours daily in a week, so it will be 5 hours, but each day there are 7 days. Each week in a week there are 7 days, so that's why we multiply by 7 to get the total hours in a week. Then we convert to seconds by multiplying by 3600. then simplify, you'll come up with that as the total energy. Then the total cost of using these appliances each week if 1 unit of electricity costs shillings 1,000. So quote the formula, substitute, simplify, and get the answer they want. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on modern physics. So if you haven't yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, such that we can all benefit as a family.